Ibexa's knowledge team, and I love Lego bricks and Japanese sculptures. I have been a user of the product for 13 years, and like 5 years ago, I decided to join the editor himself. And today, I want to have another quick overview with you of the search method available in the PHP API. And then we will have a journey into customizing the index and make a criterion, sort clause, and aggregation from this new index. And then we will customize a new search engine. There will be code all over the slides. Don't try to memorize the PHP class name, the service stack names, and such. Just follow my voice, get the big picture, the logic, and the patterns, and you will be able to reach me afterward. And I will also share with you a GitHub, so keep calm and wait for the URL. So let's start with this PHP API source method. I have identified 22 search methods in the PHP API. All of them have their own namespace for the query, criterion, and so on. And those methods can be divided in two batches. The first one is all about content. It can be divided in two subgroups, the one that are using directly the database and the one that are using search engine. The search engine is a brick you add to your infrastructure, is dedicated to search. It have a bit more features than just a database, but there is also a kind of fake search engine called legacy, which is in fact using the database. It's used for development, but when you go to production, please move to a real search engine like Solar or Elasticsearch. So you have the function that goes directly into the database that use the content service or the location service. And for the one that you are using the search engine, they are coming from the search service. And know that the product service is also using the search engine because, in fact, is transforming its product query into regular query and pass it to the search service. And suggestion service is the service that builds suggestion below the back office search bar. It was added in 4.6. The second batch or method, there is two about URL management, but most of them are coming from the commerce packages. They all have their own namespace, but since 4.6.12, all those namespaces are related to core search. So if you have already extended this area of the application, maybe check. You may have to move to core search. So now I will only focus on the content search, both the search service and content service and location service that use the database and are nicknamed filtering. Let's have a look at query. This is a regular query, and I want to focus on two properties. The query properties and the filters, they kind of look the same, but in fact they aren't. The query property is made for unpredictable content, like some text inputted in a search bar about the user, while the filter is made for limited possible value. And often they are used together, one to narrow down the other. and know that filter is cached by the search engine when you use Solar or Elasticsearch. Another features, aggregations. So it's about giving a kind of criterion and having the number of objects that respond to this criterion in the whole result of the query. This is only supported by real search engine. When you use the database, you can't use it. It will be or ignored or it's not even part of the namespace. And facet builders is only the old implementation of that. So if you find some facet builders in your old code, please move to aggregations. Now let's customize the index itself and then the query from this customized index. So what I'm gonna do is index a new data in Solar and Elasticsearch, and then use this data in a criterion, in a sort clause, and then an aggregation. And why could I index something that is not there? The idea is to not going into a new field type and something too fancy for just a demonstration. I do not know if you have already taken a look at the index in a Solar or Elasticsearch, but when you try to debug by yourself, there is something that could kind of missing for a human. It's the content type identifier. The system doesn't need it because it will map back and forth between the content type ID and the content type identifier. But as a human, I would like to have the content type identifier into the index itself. So this is what I'm gonna do. And for example, if I want to continue the customization with some more complicated field, I know it will be easy to debug directly in the search engine because I will have this little field that will help me. Before going into full customization, I just factorized few things in a trait. I will store the field type in the index. I will store his field name, and there is also the field identifier. In fact, I don't write it right away. I will index one time, and I will guess the name here. In fact, it's the field name with a suffix coming from the file type. These traits save my life because when I start this example, I choose a wrong file type. I used a field type called identifier field. I test everything with folder, and then I discover when I was starting to test with a landing page that the identifier field in fact remove underscores. So in the beginning you have no result, and in fact in landing underscore page I had to remove the underscore. So I moved to the string field to use the content type identifier as written in the database. So to index a new data for Solar and Elasticsearch, both have different implementation to handle that. Solar is using a service called the content feed mapper, while Elasticsearch uses a service subscribing to two events related to content and location. We often will have this distinction between content and location because some criterion, for example, are supported only by location, like the depth in the tree or things like that. The Solar content field mapper is pretty straightforward. Do I accept the content? In my case, it's always the case. And then mapping field is about returning an array of a new field. And I'm using my traits, so many things are factorized. and I just need the content type identifier that I have using the content type services that have been injected. As it's a service, I have to declare it and tag it. And the same for Elasticsearch. As I said, it's a bit different. This time I subscribe to an event. The content index question event and is a location counterpart. But as it's easy in the case of the content type identifier, I will use the same function. Here I use the OR to accept both. And it's about the same. It's getting the document from the event and edit it to add a field to it. And again, my trait kick-ins to don't have to matter about the field name and the field type. So I reindex on Solar or Elasticsearch. This is a piece of Solar response, but Elasticsearch responds something really similar. And now I can find the content type identifier in it and guess the underscore S and add it to the previous trait if I haven't done it yet. Okay, let's go to a custom criterion now that we have this new index. The content type criterion, content type identifier criterion already exists, so I won't create it. I will just change how it's interpreted. We will see. But when you create a new criterion, let's say from draft, from scratch, what will you need? You will need a generic criterion class that doesn't depend on the search engine. And it will only store what we want to achieve with the criterion in this query. So for example, it will be a value, a content type identifier in your case, an operator, it can be less than, greater than, a target for some case, for example, the metadata date, use it for knowing if you are searching based on the modification date or the creation date, and potentially other data if you have really advanced criterion. And then you will need something to transform this criterion for Solar into a bit of Solar query. And same thing for Elasticsearch. And if you want this criterion to also be supported by the legacy search engine, you will need also something that transforms this criterion into a piece of SQL. And same for the filter, so the content service find or location service find. Also something to transform your criterion into a piece of SQL. So let's look at the original content type identifier criterion, the one I didn't touch, so it will work the same way for the other developers. It's pretty simple, construct that receive a value, so a content type identifier or an array of content type identifiers. It just calls the parent, says I don't need the target. The operator, I will let you guess it. The guessing is that if the parent receive as a value an array, it will use the operator in. And if it receives a scalar value, it will use the operator equal. And then you have a method that specify how to use which operator, which kind of entry. And we'll refine this equal and in operator, in for array of string and equal for single string. So there is no operator yet there, but in the specification, it's there because it will have to check with what the parents guess for the criterion. Okay, so those interpreters, so we see that there is many names, visitor, query handler, and so on. So let's call them interpreter because in fact they are all working the same way. There is always a method to say, I'm working with this criterion, and a method to transform the criterion in the piece of query for the search engine or the database. So in my case, the Solar criterion will just say that I can visit content type identifier criterion by just checking that it's an instance of one. And visiting is just about crawling into all the value and building a piece of Solar query with or in between. For Elasticsearch to gain some time, I have used an abstract that allow me to just say, look into this field and just nothing more. So just for fun, the content type identifier criterion already exists. So of course is already support, and I didn't touch to the database. But let's see how I could rewrite the visitor for the database itself. I will just change the default one. The default one, as I already said, is transforming content type identifier into content ID and then build the SQL query from there. Me, I will do it a bit differently. I will make a join with the content type table. I check if I have already made this join or not. So if the criterion is used several times, I won't join it only once. And now that the join is done, I can check the identifier directly, while the built-in criterion was using ID and yes, I have all this conversion before that. So it's pretty straightforward now with just a join. For my services, so my goal is to replace the default services that are transforming the criterion. And I don't need any tag because while I'm decorating, I inherit the tags from the decorated services. So now what have we covered in a query? We have just covered the query or filter. A content type identifier is limited, so it's something more used in filter than in query. Now, let's go to the customization of a sort clause. It will be quick because it's almost the same. You have a class, not depending on the search engine to store the data for what you want to achieve with this sort clause, and then you have to decline for each search engine. The content type identifier sort clause, this time it doesn't exist, so I have to create it. But again, it's pretty simple. I just need a direction, and the empty string is for the target. I don't need one. Null is not accepted, but empty string is okay. And all the interpreters are all looking the same again. Do I work with this sort clause, and how I transform this sort clause into a piece of query. And then you can see this again. It's pretty close to the criterion, even more simple this time. I have to tag them because this time this is fully new. And just notice that the filter one, so for the content service find and the location service find, I didn't need two because the dependency injection will guess what kind of service is because of the parent it extends. So now we have covered the sort layers. I have to use my home namespace because this is a fully new sort clause this time. And for aggregation, it will look the same. A generic aggregation class. something for Solar to interpret it, and maybe you don't see it coming. This time you need a result extractor because what the aggregation is working on is not the results, so it's not covered yet. So when you make an aggregation, you have to help the system to interpret it back. But Elasticsearch, again, will need the same thing. Do you still see things coming? If you are following me, aggregation are only supported by search engine. So there is nothing more to do. This time filter and legacy won't be covered. I'm creating my aggregation. It's empty because I just need to say I want to aggregate that on that, no parameter. The visitor work the same way. Do I work with this aggregation? Yes. How to transform it? And the result extractor is about the same. Do I'm working on this aggregation? And how I transform the result from the search engine back to something usable from the PHPI point of view. To gain some more time, this time I will use an aggregation factory. So I just declare services and I have nothing to implement. This factory just need to know on which class is working. So it's the can visit things we saw in the previous example. On which field is it working? But when it comes to result extraction, I still need something to map back from the result to an object I can use in from the PHP API. So let's have a look at the K-mapper. It's pretty simple. It loops through the case, use the content type service, and I transform things back to content type from the content type identifier, which is the key. I could have even not touched to anything and let the content type identifier as strings. Here, for the example, I move to some content type object. And to gain some more time, I will handle both Elastic and Solar at the same time. Don't need a new code, so I just declare Elasticsearch services the same way that the Solar. It's almost a copy, paste, and replace. Only one thing bothers me in this is that I have made a trait to be sure to change that in the same place if I need to. This time is hardcode. So I could also took the time to create the Solar aggregation visitor by myself, to use my trait to pass the identifier. It's short, so yeah, I could do it. For the result extractor, if I want to build it by myself, it looks pretty much the same. It's about looping on the keys and transform back into content types. And now, if I do it manually with my own class, the services will look like this. So now we have covered the aggregations in our query. Yeah, that's what it. So it's a lot of repeating patterns to create your own criterion, sort close, and aggregation. To customize a search engine, what do we need this time? We need a handler that will cover the function from the search service. And we'll need an indexer that covers the command line, so like Ibexa reindex. And again, I was searching for a simple example. And my ID I didn't want to cover new search engine. I could have done it for Algolia or some AI or something complex. But I went with a simple ID. I will pass to my search engine a list of existing search engines. So it's just a parameter, and I pass it to my own search engine. And this search engine will use one of the search engine from this list. So my search engine, this is an abstract handler, and then I will develop above it. I will need the search engine factory, so I will be able to transform the alias of a search engine into the search engine itself. And then the ID is simple. Here I just show find content, but for find content info or find location, this is the same. The ID is when I want to find content, I have a method that will select one search engine, and then I will pass it the find content. And when it's something related to indexing, so index content but purge or thing like that, I just loops into all the search engine and I execute the function on it. For the indexer, same logic. This time I received the search handler. It has the list of search engine. And I received the search engine indexer factory for the same ID, transform aliases into real search engine indexer. And pretty much the same. There is some function that will use the search engine and some other that will just loop on all the search engine that are wrapped to execute the same function on it. So what could be useful with this? I have implemented in my GitHub some few examples, few use cases. It could just be about fallback. If your Solar or Elasticsearch is dead, it will use legacy instead. And when they are up again, it's coming back to Solar or Elasticsearch. It could be used for load balancing, asking a service the load of each one. Or as I test, it could just study a bit the query. And if there is nothing specific to an advanced search engine like engines like Solar or Elasticsearch, use the database instead. So if you don't have full text or aggregation, why not using the legacy instead to search in the database and reserve Solar or Elasticsearch only for really advanced queries. So from there, do you have any question? No, thank you. So thank you for listening. If you want to discuss about this, see it the example running on my laptop. You can join me in the certification room. And no, I didn't forget. This is the GitHub if you want the code for this wrapping search engine and custom criterion, custom index, etc. Thank you again.